this will be the nitty gritty under the hood tour. It was separate from the original presentation because this will go into a bit more detail. Uh, so to start off, I think I'll start in the BP top-down controller because that's the start of the sequence, really. That's the start of the feature list too. So the top-down controller, uh, to give some context, uh, the project itself is a template from the third-person view, and the top-down controller was used to control uh, some like 3D mannequin, but I've just swapped it and placed instead of the mannequin mesh, I've put the trebuchet itself. The actual like BP top-down character is the trebuchet. So this viewport that used to be the mannequin, now it's the trebuchet. There it is. I actually had to go in and rematerialize it. Actually, I can show where it was made. In the materials, yes. So I created the trebuchet material and the rope material. Yeah, here, out of all of the other textures. It didn't come with that. It just came as like a white blank canvas. So that was a fun process to learn. Uh, but yeah, it was all mapped out. It was actually pretty intuitive. Used to work. I used to. I do. I'm currently working in Unity on a project that's using shaders, and it was very similar to it. If I go into this, actually, you can see it's just a plug and chug basically. You got your texture samples all in a line, and they're actually labeled quite nicely. If I go back to here, so like for example, the metallic, I would just come into here and find okay, where is metallic? Well that's the metal bomb, but where's the it would be underscore M. They labeled it. Yeah, here it is, trebuchet M, which I had assumed was trebuchet underscore metallic, so that could just be plopped in there, and I did the same for all the other stuff. Uh, Base color was the only weird one. I think base color was D for some reason. Yeah, metal bomb D, trebuchet D. Uh, don't ask me why they labeled it that. I couldn't tell you. But once that was all set up and ready to go, we can go back into our controller because this is where all the magic happens, really. At the very top, when the controller or the object is first instantiated, when it first comes into play, we call the event begin play, and we'll start by initializing all of our variables that need initializing. So, for example, the enable input that came with the 3D template, so I just kept that in there, and we have our move speed, so that's how quickly you can move forward and backward with the trebuchet. I set it to 100, which is, if I recall correctly, that is 1 meter. We like 1 meter per second, so it's kind of slow, but that's kind of intended. The load timer, which is 3 seconds. We set our shot ready to false. We don't want to start with the shot already ready. The load time to 3 seconds. So the difference between the load time and the load timer, the load timer is the current time, the current, how much is left. The load time is what we reset the loading timer to in case we let go early and then we have to reset it. The start load animation time. So our animation sequence that came with the trebuchet, uh, it's like all in one go. It's like uh, load and fire, and it's all one thing. And I went in there and I looked at the sequence, at the actual animation line, uh, and I determined that at second 7.24 and beyond is when you're loading the trebuchet. And 0 to 7.4, if I recall correctly, is firing. The fire animation tick, 1.2 seconds, is how far into that firing animation uh, at the point where the arm is at the very top. So if you think of the trebuchet, I'll try to, if you see my window here, uh, when it's going like this, and at the very peak, 1.2 seconds into that animation, that's when it's at the very top. That's when we want to spawn the projectile. And we set the fired projectile to false. So Boolean here, we're just checking to see if the trebuchet has fired a projectile during its firing sequence. That's to ensure, and I'll go into this later, down at the bottom when I see more of the code. But it's just to ensure that, oh gosh, what was it to ensure? Sorry, it's late. Projectile. I think there was a problem when you could like fire multiple rounds off, because like it's checking every tick, so it's like 60 per tick. And if we don't have a variable looking into whether or not we've already fired during that firing sequence, then I'll just keep rapid firing it, which is kind of fun, but not intended behavior. Okay, so initialization, I should probably go a little faster on explanations here, because this is going to take forever if I keep going at this rate. We go into our event tick, which is split out into a sequence, so one thing after another. First thing, we go up here, and we actually have another sequence, so tick sequence, and then another tick sequence, and then beyond that, we are checking all of our variables, our turning left, turning rights, moving forwards, moving backs variables, and all of those variables are set here on the key press of WASDA, like I described earlier in the presentation. We're just setting true, false, and then on tick, we're checking if we're true. And if we are, we're changing the rotation and the position of the actor. And just quickly, the location of the actor is set by getting the forward vector of the trebuchet. We need to know like which way it's facing. And we get our move speed, which was set earlier. I think it was at 100, if I recall. And our delta seconds. So I think that's a consistent thing. I don't remember the exact delta. It's probably like 0.18, but whatever. Multiply it all together and add it to our current location, and that's how far we go forward or backward. Down here, so that was our first sequence. Our second, sorry, this is the sequence. Our next tick in our sequence, we come down here and we go through our countdown of the load timer. So we first check if we are loading. So if we're loading, and loading is set down here, so very similar to all of the other keyboard events. So WASD up above and down here, if our right mouse button has been pressed, then we'll set, what was it? False true. Wait. Yes, it should be setting loading to true, yes. But only if the fire animation is not blank. We cannot load the trebuchet uh, while it is in the firing animation. That wouldn't make any sense. Coming back up here, so again, if we're loading, we'll come in here and start counting down the timer while the right mouse button is pressed. So first check if the shot is ready. So if the shot isn't ready, it's false. We'll come in here and we'll set the loading timer to the current timer number minus delta seconds. So again, counting down those 3 seconds. Over here, this is just debug log, basically showing how much time is left until the timer is done. Your condition, we're looking for so this would be the loading timer is less than or equal to 0. If that is the case, so at this point, if our loading timer is less than or equal to 0, then the shot is ready. At that point, we're good to go. We can say stop loading, loading equals false, and then we'll say shot is ready. Boom, bam, bam. If we're not, so again, on this tick, so we're still on tick, 60 ticks a second or whatever it is. If we're not, if the shot isn't ready, or our loading timer is above 0, we'll come down here, and this is all the loading animation logic. So in here, we get our controlled pawn, so that gets our BP top-down character, which contains our trebuchet, because again, this is just the controller. And we feed it into a cast to our BP top-down character, and we will play the animation. We'll just start the animation. And here is a lot of logic to figure out the percent on the path of the how do I phrase it? I'll just read the code. So first things first, get our play length. So get how long the animation is. Subtract the start loading animation. Sorry, subtract the length from the start load animation. So again, start load animation was at 7.24, and then subtract the play length, and that should give us basically where we're starting at. So the total load time of the animation. Oh my goodness, it's so late. Current position is calculated via our start load animation time plus the multiplication of our percent load animation and our total loading time on animation. A lot of words. The gist of it is our load animation has a certain length, and the percentage of our way through that animation time set, if you will, is multiplied by the total time of the animation portion, or the loading portion of the animation. I don't know if I explained that very well, but that's essentially what's going on. Once we have that, and we know where we're supposed to be at in our loading animation, again based on the percentage we are through the loading animation, we just set the position of the animation to the current position that we've calculated. It's a little misleading. The set position is, you'd think it's the position of like an XYZ of like a character or something. It's not. It's the position in the animation sequence. So it's a second. And then we just set the play rate to 0 because we want to manually set the position on tick to ensure it's 3 seconds. So we don't need to actually play it. All right, that was the loading animation. Oh, excuse me. Now we have our. We went through check reset timer, I believe, or did we? Oh, I don't think we did. Okay, real quick. The right mouse button was released. Our loading is set to false. We check if the shot is ready. If it's not ready, or if we haven't reached the 3-second threshold, the loading timer is set to the load time. So I explained that earlier. However long we may have been holding it down for, set it back to 3 seconds. And then we get our controlled pawn again, so our trebuchet object. And we come in here and we cast it to our top-down character. And then we set the position back. So again, the position, the animation second, the current where we are in the animation, we'll just set that back to the very start of the loading animation time. So it resets back to the start of the load animation. Down here, if the left mouse button, so at this point we're getting into charging, so we've just basically loaded it for our 3 seconds, and now we're charging the shot. So if we press left mouse, first we'll check if the shot is ready, and if it is, we'll then also check if we're playing the fire animation, because we don't want to charge while we're playing the firing animation. And if we're not playing the firing animation, then we'll set charging to true. If we release the left mouse button, we'll set charging back to false, and we'll check if the shot was ready at this point, and if it is ready, and we've let go of release, then we can fire. We can fire the shot, and we'll set shot ready back to false, and then we'll start playing the fire animation. And this is all the fire animation logic for it. And it's basically just cast to, we get the controlled pawn again, we cast it to the top-down character again, and we get a little snaky mesh. We get the mesh from it, so the actual trebuchet mesh. I think it's called a static mesh, if I recall. We start the animation, we set position to 0, because 0, if you call over 0 to 7.24 is the firing animation sequence. And then we set the play rate, so we can actually play the animation out instead of setting it manually by tick. We set the play rate equal to our charge power times 0.25. So if you have a very small charge. If you only charge it up for a small increment of time, it'll take a very long time for the trebuchet to fire its load. And if you held it down for the maximum of 5 seconds, then of course you're at 125% of your play animation, so it'll animate rather quickly. It'll go whew, real quick. Over here, this is our next tick sequence. So here we'll check if we're charging, and if we are charging, then we'll set our charge power equal to our clamped addition of the current charge power plus the delta time, so however long we're holding it down for. And of course, the minimum between 5 and whatever the addition of the current charge power plus the delta time would be. So just ensuring we don't go past 5. And that is that portion, and then we're just printing out however long we've charged it for, just to see where we're at. And if we're not charging, and if we are playing the fire animation, which would mean the charge was, or the shot was ready to fire and we were firing it, then we can reset. We'll get the controlled pawn again, cast it as the top-down character again, and we got our our mesh snake tying into all the stuff we need for the animation. We'll get the position in the animation, and we will check to see if the start load animation time, so that's 7.24, sorry, if our current position in the animation is greater than or equal to the start load animation time. And if that's true, basically if we've reached the end of our animation, then we'll set playing fire animation to false, at which point we'll check, sorry, not check, we will set the animation back to the start load animation time, so 7.24, again, ready to start loading again in that sequence, and we'll stop it because, and by stop it I mean stop the animation. We don't need to keep playing the animation anymore. We can manually set it on tick for the load and then play it again on fire sequence when all that is ready for the next shot. And we'll set the loading timer back to load time, so back to 3 seconds, and our charge power resets to 0, and our fired projectile variable boolean is set back to false, and trebuchet is reset and ready to fire again, and we'll print that out. And finally, last bit for our top-down controller, we spawn the projectile, one of the most important parts, and is also the last in our tick sequence. So last thing we do, come down here, playing fire animation. If that's true, then we'll come over here and we'll check if we've already fired a projectile, and if we haven't, then we can proceed. Again, ensuring that we don't fire a whole bunch of projectiles, like 60 projectiles per second or whatever. We'll get the controlled pawn again, and we'll cast it to the top-down character again. So same methodology that we've been using all throughout for the animation sequences. Over here, we'll get the okay, what is this portion doing again? This is the main position, fire animation, take. Oh yes, Yes, so this portion, we're checking to see during our fire animation if we've reached that fire tick that I was describing earlier, the 1.2 seconds into the firing animation. Uh, and basically, what this is saying is get position, so our current position in our animation, is that greater than or equal to our fire animation tick? So again, if you recall, 0 to 7.24 is our firing animation, and at 1.2 seconds in that firing animation is when we would want to start spawning that projectile. Uh, and if we are over that point, then we will come in here and we will spawn a new BP projectile. And we'll give that new projectile the following variables: a transform, its position in the world. It'll be equal to, it'll actually be equal to the spawn point, the projectile spawn point, the scene component in the top-down character, the trebuchet mesh. So that was set before. I can actually show you where it is in here. It's right up here, actually. Yeah, that's the scene component right there. So when the fire tick is activated at 1.2 seconds, it'll spawn right here. And it's a little above it because this little sack actually extends above the very top of it. Back here. We'll give it our charge power, however long we've charged it up for, into its velocity power variable, which we'll use later. And we will feed it our current direction for its velocity direction. Velocity vector, however you word it. And we actually have to add a little bit of z to that vector, otherwise it'll just shoot straight out from the trebuchet. And that's not intended, we want it to arc. Once we've spawned our projectile, we will set our fired projectile to true so we don't fire off any extra projectiles. And we'll just say that we fired our projectile just to see, even though it's kind of obvious. Which leads us into the projectile blueprint. So we're going to start in here. We can ignore the camera stuff. I was experimenting and toying around with the camera following the projectile, which it can actually do. I can actually set it here if I wanted to, but I don't know, it just looked a little too weird for me. I kind of liked the perspective of the trebuchet from the back watching the projectile. Originally I had it so the projectile was too small and it was kind of hard to see, but I increased the size of the projectile so I don't need the camera follow anymore. In here, this is just checking if our projectile has hit something, and if it has, destroy it. So that'll be the same, or very similar to the fragment, but if it hits something early, then we can go ahead and destroy it and not worry about anything else. In here, so again, when it's first spawned in, we'll go in here and set its initial velocity and figure out what its peak is supposed to be. We're just setting a variable speed to 1,000. That'll be the modifier for all of the math, because again, centimeters, we'll do 100 meters per second or whatever. In here, we'll multiply, sorry, I should probably go through the executions. So we're setting a new variable, xyz velocity, which is just a vector 3. to the product of the direction vector that we fed it from the trebuchet, and the velocity power that, again, we fed it from the trebuchet. And then we will add impulse to our projectile. An impulse is just a fancy way of saying we're adding a force to it, an XYZ force, which is determined by this stuff. So again, that's our direction that the trebuchet was facing, and however long we charge it up for is multiplied by each of the directions. So longer the charge, farther it goes. Then we figure out its peak. And this is all just finding peak math. So find the initial z in our world location. And the granite ball sculpture is literally the static mesh component in our object. We find the initial z. We find the initial z velocity. And again, there's our variable xyz velocity coming in handy. I broke the pin down into its separate little components so I can get the z. And then to find the peak, if I want to try to explain the calculation here, it is the addition of both the initial z, and there's a slight discrepancy from the what's it called? The technical document. The technical document has y naught or y initial instead of z, but in Unreal, of course, z is up down. I was thinking in Unity and in physics at the time, but anyway. And it is the addition of that plus the initial z velocity squared divided by 2g, which again, 2g, 2 times gravity, 9.8 times 2, 19.6 times 100 because it's in centimeters. Add it up, and then we actually, I subtract 150 just due to the the mesh itself. It doesn't actually get to the peak if I don't offset it slightly. Weird bug, but this seems to work. And then that's all set to our peak variable. And then this was going to be the delay. So again, there would be two ways to spawn in the fragments. You either wait a second or it reaches the peak. And I realized while I was developing it that it would always just wait a second and then spawn it in, and it was less useful than I thought it would be, or less impactful, I should say. It's much more interesting to use the peak of the projectile instead of just the second delay. So that's what we did. And once we've reached the peak, so in here actually we're checking the tick again, and we're checking to see if our z is greater than or equal to the peak value. And if we've finally gotten there, then we first we get our physics linear velocity, so whatever the projectile's current velocity, that vector 3, whatever that is, we'll get it. And in here, I was experimenting with nudge values. min-max between -10 and 10. That's kind of what these were. So it was kind of like this before, but I realized I don't really need that because it already kind of fragments out. So these were ultimately unnecessary, and this addition is also unnecessary at this point, but it's there for redundancy in case I want to come back to it. We feed our vector 3 velocity into our new spawned fragment. And am I doing it here yet? No, I'm not. So we spawn the first fragment, and then we'll come in here into our while loop and spawn it 9 more times. But in essence, we spawn our fragment, giving it very similar velocity and the current position of our projectile mesh. This is what this is. And it's just a float variable, or sorry, an integer variable. Number of fragments created is set to 1, and then it's just used here in our while loop, so we'll do it just 9 more times, and this is literally the exact same. And actually you'll see here the other 9 projectiles are using randomize z, a little wiggle z, so it's not exactly the same every time. That's it for the projectile. And then the last thing would be our fragment, which is extremely simple logic. All we're doing in the fragment is A, when it comes in, set the physics linear velocity, so just set its velocity to the direction that we inherited from our projectile. And if it hits anything other than itself, so we're checking the cast fail on a fragment, BP fragment object. So if it hits anything else, it'll destroy itself. And I believe that's it. So that's the complete Under the Hood tour. Took like 20 to 25-ish hours to complete it all, figure everything out, hook it all up. And I'm actually really stoked with how it turned out. It really came out well. I was actually rather pleased that it was able to get the animation sequence up and running. I didn't have the trebuchet animation in the original feature list, but it looked too cool not to do, so figured that out. Alright, so yeah, thanks for watching.